Because velocity is negative. After the collision, we assume there's no friction or anything else, no outside influence, it's a closed system. That 13, the velocity is going to be constant, whatever it is. What does the negative tell us? Boy, that test next week is going to be exciting. What does the sign of velocities mean? Oh, by the way, a number of you for Master Set 2 submitted files that were the .heics, which Apple, is that an Apple thing? I do not have the ability here to be able to read those files. I have the ability at home, but if you submitted Master Set 2 using one of the file types that I accept, those should be graded or posted. The electronic ones I've posted. If you have the .heic, I have to grade those at home. So those would not be posted yet. But the reason why that came to mind is that last exercise, oh no, that was Master Set 3. Last exercise in Master Set 3, of which I graded some of those. Trying to determine velocity plus minus or zero. When is the velocity negative?
You're stopped. When you're stopped.
That's when it's negative?
Oh, no, it's like.
When it's zero, yes, there we go. When it's negative, what does that mean? Nope. Sign of velocity does not indicate slowing down by itself.
Your position is going negative?
Not necessarily, not the way you worded it. Maybe the intent of what you were trying to say, but not what you actually said.
Would your position be negative towards the origin or past the origin?
When your position
Or
is,
when your position is,
the sign of velocity does not indicate where you are. What's the formula for velocity?
Gravity times time. Gravity times time.
Oh, that is a specific case of if I drop an object. I'm talking more generally. And I believe in
Distance.
acceleration due to gravity.
Distance over time?
Say it again?
Distance over time?
That would be speed.
is displacement over time?
Yes, displacement over time. And displacement is also known as, what does the delta mean?
Change.
Okay, change in
This case. Your position.
position. Yeah, okay. So it's a change in position over time. So I got a fraction here. Change in time. We can't help but move in one direction. So that's a positive number. So when is the velocity negative?
Because your displacement is
Okay, and or the position change is negative. What does a negative position change mean?
To the left. To the left.
What I believe you were thinking, yes, but the way it was worded, no, not necessarily. You made an assumption. Why'd you say to the left?
0, to the left is minus, to the left negative, to the right positive.
Okay, so we can take that, Elizabeth?
Is it when you're behind the starting point?
Ooh, no,
Or,
it depends on if you're looking at instantaneous velocity or overall average velocity. If you're looking at average velocity, yes, when you're on the negative side of the starting point. Looking at instantaneous velocity, read me real close. You're just too specific.
Because she decides left was negative.
Say it again?
Because she decided left was negative.
Yes, she did decide that. So in general, when is velocity negative? What? Please talk louder. I'm old, tinnitus, and I believe you are talking softly. It's not just my hearing.
is it when you decide it's negative? When you're.
Once you've decided the positive or negative direction, what does the negative sign for velocity tell us?
When your position is.
If I get a number line here. Not gonna remove it. Let's do it over here. I got a number line. I'll put the origin there. We'll make that 1, 2, 3, 4, -1, -2, -3, -4. So I've made positive that way. If I go from here to here, is that a positive change in position or a negative change? All right. If I go from here to here, positive change or negative change? Okay, so it has not, so where I am really has nothing to do with the change in position. If I'm here and go to there, here and go to there, okay. So if I have so when I had a positive change, which was, that was my positive change, that was a positive change, will my velocity be positive or negative? Sounds so quiet though on that one.
Positive.
Are you? Okay. If my change in position is positive, my velocity is positive. What's common about those two things I circled in red?
You're going the same direction.
Yes, in which direction is that?
To the positive.
Yes, so what would negative velocity mean?
When you're going to the negative direction.
Yes, that's what the sign means. So in green here, this negative just means that the blob, when they stuck together, is now moving in the negative direction. So they're gonna crash into each other and go that way, given the green convention. Now let's get rid of this yellow. See how well I can do this without losing everything. Oop. What will I get rid of? I lost a box. Oh wait, that's not what I want. All right. This is sort of a quick review of what we did earlier. Let's bring energy into it. What is the initial kinetic energy of the 5 kilogram mass? Or how would you find it?
One and a half times 5 times 15.
1.5 times 5 times,
15.
not times 15,
3.
9.
3 squared. The formula, which all of you have committed to heart, the formula, you know, I go 1/2 times 5 times 3 squared.
22.5.
0.5. Units?
Joule.
Yes. All right, so that is that kinetic energy. So the kinetic energy initially of the 8 kilogram mass.
One and a half times 8 times 2 squared.
Okay, which is
16. 16.
something say again?
1.6.
1.6. All right, 16.
Joule.
So what is the total kinetic energy before the collision? Put it over here. The initial equals. Or how would you find it? All right, I'm not asking for anything particularly complicated here. How do we find the total initial momentum?
Momentum equals mass and velocity.
What? Like, say that again?
Momentum equals mass and velocity.
Momentum is mass times velocity. How do we get this -1 though?
15 minus 16.
Will it be 38.5? 38.5,
30, yes, it would be 38.5. How do you get 38.5?
adding both together.
Yeah. So you get the total by just adding them. So that's my initial kinetic energy. That's my final kinetic, or sorry, initial for the 5, initial for the 8. My total initial, add them up. We got the -1 by adding 15 and -16. Now, my final kinetic energy. Hint, it's not 38.5. It's supposed to be an F. It's funny. How would you find the final kinetic energy?
Would you subtract them?
Probably without a calculator, it's gonna be difficult to do, but.
-0.5.
What'd you get?
-0.5.
Kinetic energy can't be negative.
Yeah. We have 1/2m v final 13. Minus -1/3.
Technically, it's speed squared, that's the velocity, so like even if you throw the negative in there, when you square it, it'll
Yeah,
go away.
square.
So that's,
Yeah, I know this one. And this.
yeah, so one of those, so basically it goes 1/26, which is 0.025, is 0.04, 6.0397.
I got 0.03846.
846.
Yeah.
Units?
Joule.
All right. So we started out with over 38 joules of energy, and we end up with almost zero amount of kinetic energy. There's definitely a loss here. Matter of fact, for a collision with just a closed system collision, when they stick together, that's when we can get the most loss of kinetic energy. Right?
Why is the initial bond not the same?
For kinetic energy?
Yeah.
Because when they exert a force on each other, those forces are normal forces, which are non-conservative. Energy is lost. Where does the energy go? If I look at the entire universe, the total amount of energy in the entire universe should stay relatively constant. Energy has to go somewhere. It actually, typically in something like that, they collide into each other. That energy becomes internalized, and they would heat up just a little bit. They'd get a little bit warmer. Just like if you smack your hands together, your hands warm up some. All right, so let's do another one, except they won't stick together.
I have a quick question.
Yes.
How did you get the 1/13?
I worked out that far that the total momentum is equal to the total mass times velocity. So I'm now solving for V final. I'm multiplying 13 times that, so to isolate it, I divide both sides by 13. That's where I got the 1/13.
Okay.
If on a calculator you came up with some decimal form of it, then that works too. Any other questions?
And the decimal form, do we round it off or do we just put all the numbers?
Round it off to something reasonable. On a test or quiz, I'm more flexible about that than on a lab. I'm expecting proper rounding. On a quiz or test, get close enough so that I won't notice that if there's a mistake. Let's see. I'm just going to pick numbers that are convenient for me. Is that the one I want? Here we go. 2514. So 2 kilogram mass going to the right at 5 meters per second. And then a 4 kilogram mass going to the left at 1 meter per second. They are going to collide. They will not stick together. Afterwards, I guess I do have to tell you that much. I got too many numbers written down here. Okay, so that is, all right. So afterwards, the 4 kilogram mass is going to the right at 2 meters per second. So, first off, the 2 kilogram mass, what is its final velocity? So this is just, got a collision, conservation momentum. We'll just run through that and then we'll take a look at the energy involved. So, let's find our individual momentums. The initial momentum of the 2 kilogram mass is what?
10. meter per second.
All right, I'm gonna save myself some time here. I'm just gonna create a unit. All right, positive? Negative?
What's
All right, so we are establishing to the right is positive. All right, of the 4 kilogram mass, the initial momentum,
four? Negative four.
-4, what I'm calling a Descartes. So my total initial momentum is okay. What's my total final momentum? Pardon? Yes, it's the same. That's that conservation momentum thing. So P final should be the same as the initial, total initial. So what is this P4 final? What's the final momentum of my 4 kilogram mass? Come on, someone just be brave enough to say it.
10? 10?
10?
10?
10? No, not 10.
Oh, 4 minus negative 4.
Final, we're here.
Oh,
I think somebody just said it.
8.
eight.
Yep, 8.